welcome to this video where we're going to show you a small demonstrator about the DEWI gateway for the rail domain. ITI, Instituto Tecnológico de Informática, is leading the technology item 4.3 called Communication Stack for Train Wireless Sensor Networks. In this technology item, we are investigating and developing communication stacks for wireless sensor networks and communication devices with the upper layers, such as the DEWI gateway. With this technology item, we are also contributing in the work package 4.3 called Centralized Onboard Solution for Seamless, Safe and Reliable Wireless Sensor Network Integration. In this work package, we are collaborating with the implementation of a prototype DEWI gateway for the rail domain. Here we can see a schema of the DEWI gateway with the main building blocks and 4 interfaces with the outside of the gateway. We can see the level 1 adapter, which interfaces with the wireless sensor networks of the train. We have the level 2 adapter, which interfaces with the outside of the train. This corresponds to the level 2 of the high-level architecture in DEWI. On the bottom we have the Smart Integration Platform, which communicates with the systems and networks in the train, mainly legacy devices and safety systems. This device follows safety rules and protocols and can act on the train when it detects any kind of problem. It reads the information from the train and also from the wireless sensors across the DEWI gateway. On the top of the image we can see the internal client endpoints which connect with internal services in the train. We didn't have these services before. These services have been created for the new capabilities we can have with these wireless sensor networks. This is, for example, the case of screens along the train for information, location services, comfort and climate controls, height services, freight monitoring, and etc. These new services communicates directly with the DEWI gateway, can get direct information from the sensors using the events-driven interface, or it can request for store data across the services-oriented interface, or can get information with added value across the data fusion interface. Inside the DEWI gateway, we can see the core, which is the MQTT broker. We have selected MQTT as level 1 protocol. This is an application layer protocol, publish subscribe. It's agnostic to the payload, so we can send any information we need, and supports security and 3 levels of quality of service. All the sensors in the rail domain are communicating with MQTT protocol. This communication reaches the level 1 adapter and gets inside the MQTT broker, and this broker sends the information to any interested client in this telemetry data. For example, it can send information about open doors to the Smart Integration Platform to take any kind of action. It can send information about climate to the internal client endpoint, or it can send all the information to the data fusion to store it and process it later. We have a local database where all the telemetry data is stored. Any client can get into this local database to get information across a REST API. This local database has a catalog to manage the assets and the measurements, has control of the data integrity, has provision of assets. We also have authorization and authentication for MQTT and for the resources published there. We also have a security manager, quality of service, and many other small building blocks.
Here at the laboratory we have the DEWI gateway prototype, and in order to test it we have set up a virtual train conformed by 4 different cars and the header. and each car it's simulating a wireless sensor network, transmitting information of temperature, humidity, weight, and integrity. In first place, we can find the header of the train. Here, an embedded PC contains an MQTT broker along the rest of the modules of the DEWI gateway and the network infrastructure. Then we can find different laptops, each one simulating a wireless sensor network in a different car of the train. Each laptop is running a PHP MQTT client, sending all the important information to the broker independently. In practice, each laptop corresponds to one or more wireless sensor networks, such as these ones, which are being developed by each partner in their corresponding work package and will be connected to the DEWI gateway in the final demonstration. So in one hand, we have the MQTT publishers simulated by each of the laptops, and on the other hand, we can find internal clients that subscribe to this real-time data flow in order to perform control and monitoring tasks. As an example of these internal clients, we have a web application which implements an MQTT subscriber in order to perform integrity and freight monitoring. We are monitoring temperature, humidity, and weight parameters, and also integrity information to see if every car is still connected to the train. Here we can see on the top of the screen this integrity information in the form of a train. Each car will alert if it's disconnected. Then on the bottom left side we can find real-time charts of temperature and car weight. And on the right side we can find a live feed with alerts of these parameters if they trigger some thresholds, and also an extended log showing all the messages MQTT has sent to the DEWI gateway.
For this demonstration, we are going to check how the integrity sensors work. To do so, we are going to simulate the disconnection of a car in order to verify if messages are received by the interface. In first case, we are going to simulate the disconnection of the car 4. We are going to unplug the cable to simulate the network, that the network is broken. Now we can see in the interface that messages are not received by the interface, by the header of the train. To recover the integrity, we plug again the cable and check that again messages are received. The second test will consist on disconnect an intermediate car, the car number 2, in order to verify that the rest of the cars are separated from the header of the train. We unplug the cable and now we can see in the interface that cars 2, 3 and 4 are disconnected from the header of the train. To reestablish the connection, we plug again the cable and we can see that all the train is completely connected.
At this point, work package 4.3 is already finished. We are implementing now the final version of the DEWI gateway for the demonstrator package in the rail domain. This final version will finally connect with real devices in the wireless sensor networks spread along the train. It will also contain some new modules and improved modules for security and quality of services. It will be tested in laboratory, connecting with the modules and devices developed by the other partners, and it will be tested also in a real scenario in the real train. We are also spending some efforts in the interoperability work package in the rail domain for looking for links and connections with other domains. We are analyzing now the requirements of the building domain and adapting this gateway to be used also in their scenarios. And we are building a prototype which will be tested in the probably 2 demonstrators of the building domain. Thanks for watching.